Picture this. You're walking through a medieval village at dawn, and the first sound you hear isn't roosters crowing or church bells ringing, but the rhythmic hammering of metal on metal on metal echoing from the blacksmith's workshop. The building glows orange from the forge fire that's been burning since before sunrise, and smoke pours from the chimney carrying the distinctive smell of burning coal and hot iron. Inside, the blacksmith and his apprentices are already deep into their daily work, transforming raw iron into the tools, weapons, and hardware that keep medieval society functioning. This isn't just a simple craft shop, but a sophisticated manufacturing facility that combines metallurgy, engineering, and artistic skill to produce items that are essential for survival in the medieval world. The workshop buzzes with activity as multiple projects proceed simultaneously, each requiring different temperatures, techniques, and timing that the master blacksmith coordinates with the precision of a symphony conductor. The layout of a medieval blacksmith's workshop was carefully designed to maximize efficiency while ensuring safety in an environment where open flames, molten metal, and heavy machinery created constant dangers. Every element of the workshop was positioned to support the complex processes required to transform raw iron and steel into finished products, from the central forge that provided heat and light to the specialized work areas where different types of metalworking took place. The forge itself was the heart of every blacksmith's workshop, a sophisticated heating system that could achieve and maintain the precise temperatures required for different metalworking operations. Medieval forges weren't simple fire pits, but engineered systems that used bellows, fuel management, and airflow control to create optimal working conditions for heating, shaping, and heat-treating metal objects. But here's where medieval blacksmith workshops become truly fascinating. They weren't just individual craft operations, but integrated manufacturing systems that coordinated multiple specialized processes, managed complex supply chains, and produced finished goods that met demanding quality standards while serving diverse customer needs across entire regions. The bellows system that powered medieval forges was a sophisticated mechanical device that required careful construction, regular maintenance, and skilled operation to provide the consistent airflow necessary for maintaining proper forge temperatures. Large leather bellows were operated by apprentices or powered by water wheels, creating forced air systems that could achieve temperatures exceeding 2000 degrees Fahrenheit. The construction of these bellows systems involved skilled leather workers who created airtight chambers using specially treated animal hides, metal workers who crafted the valve systems and connections, and carpenters who built the wooden frameworks that supported the entire mechanism. The maintenance of bellows required daily inspection for leaks, regular oiling of leather components, and periodic replacement of worn parts that could affect airflow consistency. The fuel used in medieval forges varied by region and availability, with charcoal being preferred for its clean burning and high heat output, while coal became increasingly common in areas where it was readily available. Blacksmiths understood the properties of different fuels and selected appropriate materials based on the type of work being performed and the quality requirements of specific projects. Charcoal production was often integrated into blacksmith operations, with some smiths maintaining their own charcoal kilns or contracting with specialized charcoal makers who understood the precise burning techniques required to produce high-quality forge fuel. The charcoal had to be properly sized, thoroughly dried, and stored in dry conditions to maintain its burning characteristics and heat output. The anvil represented the blacksmith's most important tool, a massive block of steel that provided a stable work surface for shaping hot metal through hammering, bending, and forming operations. Medieval anvils were carefully crafted to provide optimal working surfaces, with different areas designed for specific operations like drawing out metal, bending curves, or creating sharp edges. The creation of quality anvils required master metalworkers who understood the complex metallurgy involved in creating tools that could withstand thousands of hammer blows without deforming or cracking. Anvils were expensive investments that represented significant portions of a blacksmith's total equipment value, and they were often passed down through generations of craftsmen who maintained and refurbished them throughout their working lives. The tool collection maintained in medieval blacksmith workshops was extensive and specialized, including hammers of various weights and shapes for different forming operations, tongs designed for gripping hot metal safely, files and grinding stones for finishing work, and measuring devices that ensured accurate dimensions and proper fit for finished products. Each tool had specific applications and required proper maintenance to function effectively. Hammerheads needed regular dressing to maintain proper striking surfaces. Tongs required adjustment to grip different sizes and shapes of hot metal. Files needed cleaning and proper storage to prevent damage, while measuring tools required protection from heat and moisture that could affect their accuracy. The water systems integrated into blacksmith workshops provided essential services for quenching hot metal, cooling tools, and maintaining safe working conditions in environments where fire and extreme heat created constant risks. Quenching tanks, cooling basins, and water storage systems were strategically positioned throughout workshops to provide immediate access during critical metalworking operations. The quenching process was critical for achieving proper metal hardness and required precise temperature control and timing that could determine the success or failure of entire projects. Different metals required different quenching media, with water providing rapid cooling for carbon steel, oil offering slower cooling for alloy steels, and air quenching used for certain specialized applications. The workspace organization in medieval blacksmith shops reflected sophisticated understanding of workflow optimization, material handling, and safety management that allowed multiple craftsmen to work simultaneously on different projects without interfering with each other or creating dangerous conditions. Traffic flow patterns within workshops ensured that hot metal could be moved safely between workstations, finished products could be stored without damage, and raw materials could be accessed efficiently during production operations. The placement of equipment, storage areas, and work surfaces created logical sequences that minimized unnecessary movement while maximizing productivity. The raw material storage areas in blacksmith workshops required careful organization and protection systems that preserved iron, steel, and other metals while providing easy access during production operations. Different grades of iron and steel required separate storage areas, while specialized alloys and precious metals needed secure storage that prevented theft and contamination. Iron storage involved protecting metal from moisture that could cause rust and deterioration, organizing materials by size and grade for efficient selection, and maintaining inventory systems that ensured adequate supplies while minimizing waste. Steel required even more careful handling due to its higher value and specific composition requirements for different applications. The inventory management systems used by medieval blacksmiths tracked raw materials, work in progress, and finished goods through detailed record-keeping that ensured adequate supplies while minimizing waste and controlling costs. Master blacksmiths understood material science and maintained careful control over metal quality and composition throughout production processes. Record-keeping involved tracking the source and quality of iron and steel supplies, documenting work orders and customer specifications, monitoring production progress and completion dates, and maintaining financial records that tracked costs and profits for different types of work. This documentation was essential for managing complex operations and ensuring profitable business operations. The apprenticeship programs operated in medieval blacksmith workshops created systematic training systems that preserved technical knowledge while developing skilled craftsmen who could maintain quality standards and continue metalworking traditions. Apprentices progressed through carefully structured learning programs that combined theoretical education with hands-on experience under master supervision. The training progression typically began with basic tasks like maintaining fires and organizing tools, advanced to simple metalworking operations under close supervision, progressed to independent work on straightforward projects, and culminated in the creation of masterpiece projects that demonstrated full competency in all aspects of the trade. The guild regulations that governed medieval blacksmith workshops established quality standards, pricing structures, and professional conduct requirements that protected both craftsmen and customers while maintaining the economic viability of metalworking trades. Guild membership provided access to raw materials, technical knowledge, and marketing networks that were essential for successful blacksmith operations. Guild standards covered everything from the quality of raw materials and finished products to the training requirements for apprentices and the pricing structures for different types of work. These regulations ensured consistent quality across all guild members while preventing unfair competition that could undermine the entire trade. The product diversification in medieval blacksmith workshops included agricultural tools like plowshares, hoes, and scythes that were essential for farming operations, household items like knives, locks, and hardware that improved daily life, military equipment like weapons and armor that provided protection and defense capabilities, and architectural hardware like hinges, nails, and decorative ironwork that enabled construction projects. Each product category required different skills, tools, and techniques that blacksmiths had to master to serve diverse customer needs. Agricultural tools demanded understanding of farming operations and soil conditions. Household items required attention to daily use patterns and durability. Military equipment needed knowledge of combat requirements and metallurgical properties, while architectural hardware involved coordination with construction projects and building requirements. The quality control procedures used in medieval blacksmith workshops ensured that finished products met performance requirements and customer expectations through testing, inspection, and certification processes that verified strength, durability, and functionality. Master blacksmiths staked their reputations on product quality and developed rigorous standards that protected their professional standing. Testing procedures included stress testing of tools and weapons, dimensional verification of hardware items, hardness testing of cutting edges, and functional testing of moving parts like locks and hinges. These tests were performed before products left the workshop and were often repeated during final inspection with customers present. The seasonal rhythms that shaped medieval blacksmith operations reflected agricultural cycles, military campaigns, and construction seasons that created varying demand for different types of metalwork throughout the year. Spring brought demand for agricultural tools, summer emphasized construction hardware, autumn focused on harvesting equipment, while winter allowed time for weapons production and equipment maintenance. Seasonal planning involved anticipating demand patterns and adjusting production schedules to meet peak requirements while maintaining steady employment for apprentices and journeymen. This required understanding of local economic patterns and coordination with suppliers to ensure adequate raw materials during busy periods. The customer relationships maintained by medieval blacksmiths included individual farmers and craftsmen who needed tools and equipment, wealthy landowners who required weapons and luxury items, religious institutions that commissioned decorative ironwork, and municipal authorities who needed infrastructure hardware for public works projects. Each customer category had different requirements, payment schedules, and quality expectations that blacksmiths had to understand and accommodate. Farmers needed durable, functional tools at reasonable prices. Wealthy customers wanted high-quality items with decorative elements. Religious institutions required specialized items for ceremonial use, while municipal contracts involved large quantities of standardized hardware items. Medieval blacksmith workshops established precedents for modern manufacturing, quality control, and technical education that continue to influence contemporary metalworking industries. The emphasis on craftsmanship, technical expertise, and customer service evolved directly from medieval blacksmith traditions. Most importantly, medieval blacksmith workshops demonstrated that sophisticated manufacturing can be achieved through skilled craftsmanship, careful organization, and systematic approaches to production that create products of exceptional quality and durability using relatively simple tools and techniques. So what did a medieval blacksmith's workshop look like? It was a carefully organized manufacturing facility that combined advanced metallurgy with systematic production methods to create essential tools, weapons, and hardware that enabled medieval civilization to function and develop. These workshops represented the pinnacle of medieval industrial capability, demonstrating that skilled craftsmen working with appropriate tools and techniques could achieve remarkable results without modern technology. They proved that quality manufacturing depends more on human skill, systematic organization, and technical knowledge than on advanced machinery, creating production systems that served their communities effectively while maintaining standards of craftsmanship that modern manufacturers often struggle to match. The next time you see modern metalworking or appreciate the precision of contemporary manufacturing, remember the medieval blacksmith who combined fire, iron, and human skill to create tools and weapons that shaped civilization, working with techniques and standards that established foundations for all subsequent metalworking traditions and manufacturing excellence. If you enjoy the hidden sides of medieval life, hit subscribe and give this video a like.